So today I will explain the source which I have put into my channel, and we'll try to understand the underlying concept to solve those questions. Okay. So the numerical which is in front of our screen is just I put the shots of it yesterday. I want to just explain the concept in the solving of this numerical, right? So here in this question, this is a question I've taken from NCRT, okay, class 9. Even the same kinematics concepts can be applied in class 11 also, and even many competitive examinations, right? So today the numerical, what is the question? I will explain it first. Okay. The question is that there is a building, okay, there is a building and a stone is dropped, right? There is a building and a stone is dropped from the top of the tower. This is the tower, this is the tower, and from the top of the tower a stone is dropped, right? A stone is dropped and we need to, a stone is dropped and we need to find in after how much time the splash sound is heard, right? After how much time the splash sound is heard. So what is the data that is given into the question? Let us see. Accordingly we will start solving it. Just a minute, I am looking after some fresh pages. So how is your preparations ongoing, students? Hopefully good. Yes. So actually many of the pages is filled. I'm taking a fresh page. Let's say here. So in this question, a building is there. Let's say this is the building. This is the building. These are the multiple floors, let's say. I'm trying to making it interesting. Okay. And a stone is dropped. Let's say this is the stone which is dropped from the top of this floor, from the top of the building, right? I'm writing it, it's a stone. Okay. A water level is there at the bottom of the, just near the floor of the building, at the bottom floor, and that means the ground floor, right? So water layer is there. So let's say if this is the water level, okay, a stone is dropped from top of a tower 500-meter high. So the height of this tower is given to you. What's that? 500 meter. 500 meter of tower is given to you. Now, a stone is dropped from the top of a tower 500-meter high, right, into a pond of water at the base of the tower. So this is the pond of water at the base of the tower. Let's say this is the pond, right? When is the splash heard at the top? You are just sitting over here. You are here, right? When you are hearing the splash sound. When is the splash heard at the bottom, at the top? Given acceleration due to gravity g, the value of g is given to you as 10 meter per second square, right? And the speed of sound is 340 meter per second, right? So students, think, when the stone is dropped from here, how you will hearing the sound? The stone will go from here in this way, isn't it? And it will just dip into or strike the floor of, strike the pond. and when it strike the pond, then only the sound will be generated, isn't it? When it strikes the floor, strikes the floor of the or the level of the pond, the top level. So you need to understand, when you are dropping the stone, initially you are not going to listen the sound of this stone. The sound of this stone is only audible to you when it goes in this way, this way, this way, this way. Hi Taeyong Han. Yeah. Let's say from A it's going to B, and from B the sound is generated. So the sound, sound also needs a media to travel. So here it's an air media. Okay. So when sound is generated, it starts going, it is just going upward and just reaches to you in this way. It reaches to you in this way. And when it reaches up to this level, you are able to hear the splash sound. Right? So what we are going to calculate, since the stone is going this from A to B, and from B it's going back to A. So let's say I'm just mentioning it separate, C and D. Right? Now, when, what is the time? Suppose you are dropping the stone. Okay, stone is dropped. Since a stone is dropped, we can say the initial velocity of the stone is 0 meter per second, isn't it? The initial velocity of the stone is 0 meter per second. Now, what's next? The initial velocity of the stone is 0 meter per second. Hi Tiong Han, sorry, wrongly pronounced your name. How are you? Hope doing fine. Yeah, so today we have taken the question of the study shots. What's that? A stone is dropped from the top of a tower 500-meter high. This is the tower which is 500-meter high, and it goes into a pond of water which is located at the base of the tower. You can see here, right? When is the splash sound heard at the top? So you need to understand the question. In this question, you are just not sitting over here. Okay, you are sitting over here on the top. Okay, so when the sound reaches up to this level to D, then only you will be able to listen, because D, A all are equal. Okay. So when you are dropping the stone, the initial velocity is 0 meter per second, right? So I am just considering for AB, for AB, for the journey of AB. AB, I mean to say a stone journey. A to B is the stone journey, and you will be listen the sound when the sound reaches generate from point B and C and reaches back to D. So the total time will be considered, that is the total time of traveling of this stone to pond, and from the sound which generates, then it travel from C to D. That means stone journey from A to B, stone journey from A to B, and sound journey, from C to D, right? So two parts are captured over here. When the stone is going downward, so this will give you one time, let's say T1, and I'm just circling it with different color, T1, and here you are getting T2. That means the sound journey by CD. Now During A to B, what is the data given? U equal to 0. U is 0. So I'm writing it over here. Let me take some different color. Yeah. Here U equal to 0, right? Initial, because the stone is dropped, so initial velocity is equal to 0 meter per second. And it travel a distance of 500 meter, that is equal to the height of this building, right? So 500 meter is the distance traveled, 500 m, right? Now just apply the equation of kinematics, then you will be able to calculate T1 here. So simply putting up the values, S equal to ut plus half at square. Why we have taken this? I will explain it. S equal to ut plus half at square, but A is g over here, so we will put g. What is g? G is the acceleration due to gravity. This is 10 meter per second square. This is given to you, right? Perfect. Now when you are knowing this value of S, hat young hand, you can put up your queries into the chat. I will take it up. So let us solve this numerical first. In this numerical, it's given that a stone is dropped from the top of a tower 500-meter high. The tower is shown to you into a pond of water at the base of the tower. So the pond is located over here. So there will be two part which is covered. That is A to B, stone journey, then C to D, sound journey. When A to B is covered, then C to D is covered, and then only you are able to listen the sound, right? Then only you are able to listen the sound, right? Now here what we did, we just put up the values, and after putting up the values for S equal to 500 meter, let us put it. Sorry. So putting S, that is the net displacement, you can see here it's 500. So putting up the value of 500 for the AS, that is the net displacement when the stone is going downward. For the AB journey I am considering, okay? For the AB journey I am writing over left side. So for the AB, S is 500 and U is the value which is the initial velocity when the stone is dropped, so that is 0. So U into T will be equal to 0. So here I am taking T as T1. Why T1? Because T1 is the time taken by the stone during the journey. It traveled from A to B, right? It's traveling from A to B. It's A to B. So from A to B, the displacement is 500, initial velocity is 0, so the second term will be 0, and half gta square. Half gta square will be equal to 1 by 2 into the value of g is 10 and t1 square. So from here you are getting the value of t1. That means for the AB journey, the stone journey, you are getting the value of t1. Just simply calculate it. 500 into 2 will be 1000. 1000 divided by 10. This 10 will come to the denominator of LHS. And this will give you T1 square. Take a square root. So we will get T1 as 10 seconds. So you have calculated the value of t1 as 10 seconds, right? So t1 is equal to 10 seconds you have calculated, right? So when the stone is dropped from top of the building to the pond, the time it will take is t1 equal to 10 seconds as we have calculated it over here, right? So this 10 seconds is the time taken by the stone when it reaches to the pond, right? This is the time taken by the stone to reach the pond. Now total 10 seconds of time is taken. Only 10 seconds you can see here. Only 10 seconds, right? And what is the next time? When you will be able to hear the sound? Are you able to hear the sound when the stone reaches B? No, because sound is generated here. At C, sound generated. In fact, it's generated at B and sound starts traveling. Sound sound traveling. The sound journey started from C. Sound is started from C and reaches to D. When it reaches to D, this is at the level of yours. So then only you are able to listen at this point, right? So do one thing. You have already calculated the time taken by the stone to reach the pond. That is 10 seconds. Now what is the time taken by the sound? So sound is generated when the stone hits the pond at B, and then sound is generated, let's say from, and it travel from C to D. So this is the sound path. So sound will go along this way, C to D. When it reaches to D, you are able to listen because this is at your level. So for the first part, we have calculated 10 seconds of time taken by the stone to reach the pond. And after that, sound is generated. And when sound is generated, let's say the sound just follows the path of CD. Sound follows the path of CD, right? Sound follows the path of CD, right? In this way, what is the time taken by the sound? You know the velocity of sound? Velocity of sound is given to you. What's that? Velocity of sound is given as 340 meter per second, right? And that will be equal to net displacement by time. So what is the net displacement? This is 500. Again 500 meter is captured over here or traveled by the sound. So just put the value of 500 into the RHS, because velocity equal to displacement by time, right? So here 500 will be divided by the time. In here the time will be t2, because this is for the CD journey from C to D, right? So you are knowing 340, you are knowing 500, so you will be able to calculate the variable t2. So t2 is calculated by 500 by 340. Just cancel it out, 0 0. And 50 by 34. 50 by 34, let's do one thing. from 2 is 25 and from 2 is 17. So 25 by 17 you are having. So 25 by 17 is equal to 17, 1 times 17, then 8 will be balanced, put the decimal, 80, 17, 4, 68, then 12, then let's say 1.4 and something, and we are not going into the deep. Okay, so 1.4 is the value of t2, and the this is the time taken. 1.4 second is the time taken by the sound from C to D. So I'm writing it, let's see here, t2 as 1.4 seconds. 1.4 seconds. Now total time is given by this t1 plus this t2, right? And what's the value of t1? T1 is 10 seconds. And what's the value of T2? T2 is 1.4. 1.4. So this will give you the total value, total time taken by the stone to reach the pond, and after that sound is generated and sound travels back from C to D. So these two journeys will be covered, and the total time is 10 seconds when the stone reaches the pond, that is A to B, and from C to D the time taken is 1.4. So just add up both these times to get 11.4 dot 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 something. So this meter is the time, sorry, not meter, it's seconds. This seconds is the time taken by the stone when it reaches the pond and the sound is generated and it reaches back to your ear. So the question was that when is the splash heard at the top? So the splash is heard after 11.4 seconds when the stone is dropped. From the time the stone is dropped, let's say it's 0 seconds, and it goes and hit the pond and the sound is generated and sound travels the path of CD, let's say. I'm just taking it separately so that these two things will be captured. One is AB, another is CD. The first is the stone journey when the stone is dropped and it reaches the pond, and the second is the sound journey, that is when the sound is generated and it travels the path of CD. So two paths will be captured, AB and CD. So for AB, we have taken initial velocity 0, displacement is 500 meters. So applying S equal to ut plus half at square. Acceleration due to gravity is g over here. So putting up the value for t equal to t1, because this is for the journey t1. That means this is the time taken by the stone to reach the pond. So that is calculated as 10 seconds, right? And in the second part, what we have taken, the sound is generated, then sound follows the path CD, right? So for the CD, we will take the time taken by the sound to reach the top of the building is T2. So T2 is the time taken. Now this T2 can be calculated. We are knowing the velocity of sound as 340 meter per second. Here you can see 340. It's also given into the question. And displacement by time will give you the velocity of sound, right? So velocity of sound is 340. So you just putting up the value equal to displacement, that is again the same 500 meter will be traveled. So sound will also travel the same path 500 meter as the stone travels during the t1 time. So just putting up the value of displacement as 500, and in place of t is t2, that is the sound journey, right? So when you solve it, you will get 1.4 seconds around. So total time is the time taken when the stone is reaching to the pond, and the time taken, that is t1, stone is reaching the ground, and t2, the time taken when the sound is reaching to the top of the building, that is t2. So t equal to t1 plus t2, we have added both of these to get time as 1.4, sorry, 11.4 seconds. So this is the total time taken by the stone when it reaches to the pond, and again sound is generated and sound reaches to the point of D, that is the top of the building. So after 11.4 seconds you will be able to listen the sound, students. I hope you understood it. Yes. So such question of kinematics or the displacement, velocity, you are able to solve it. Just there are, just applies both. There are only three equations into this. Okay. V equal to u plus at, s equal to ut plus half at square, and v square minus v square equal to 2as. So just apply these three concepts, three formulas, and you will be able to solve all questions of kinematics, right? So I have just taken this question over here to just explain it, because in 1 minute of time it's very difficult to explain the sorts in sorts. So that's why I just explained it. Hope you are able to understand it. Should I explain it again? Quickly revising in 10 seconds. A stone is dropped. So a stone journey from A to B. When it strikes the pond, then the splash sound generated. Then sound journey starts from C, then it reaches to D. Why I have taken C and D? Because I am just trying to mention it separately so that you will be able to understand. So total two parts: a stone journey, then sound journey. A stone journey is AB, sound journey is CD. For AB, you are having initial velocity 0 because the stone is dropped. S is 500 meter, that is the displacement. Apply the formula S equal to ut plus half gt square. You are knowing the value of g. U is 0, S is 500. 500 is the displacement, that is the stone is covering the total height of the building because it is going down to the ground floor. So 500 meter is the displacement. So you are getting here, you are getting t1 value as 10 seconds. Now you have to calculate t2. This is the total time. Total time is t1 plus t2. For the T2, the sound is generated from here, from the pond floor, or the from the surface of the floor, and the second part is covered, that is sound journey CD. So you are knowing the velocity of the sound 340 meter per second, it's given, and displacement again the same 500 meter to the top of the building. This is equal to 500 meter. This will be captured or covered by the sound, and time taken is T2. That is the second part of the journey. That is the sound journey. So here we have calculated T2 as 1.4 something seconds. In decimals I have left it. So total time is T1 plus T2. The value of T1 is calculated. What's that? That's 10 seconds. So it's simply I have added 10 plus T2 value is 1.4. 1.4. So it's 11.4 seconds is the total time when you are able to listen the splash sound, right? So the splash sound is heard after 11.4 seconds, right? Now students, I am just changing the question now because it's already, I've explained it in detail. I will take some separate question. Let's take some question of quadratic equation. Okay, there is a question which I have taken. Mm, let me write it over here. 1 minute. 1 minute, students. Yes. So this is a question of quadratic equation where a plus b is given as 15. A plus b is given as 15, and the reverse of these numbers, the two numbers, one a and b, the sum of these reverse of these numbers is given as 3 by 10. So what are the value of a and b, we need to calculate, right? Here you can see a plus b is 15, right? So let's say this is equation number 1 and this is equation number 2. Since 1 by a plus 1 by b is 1 by a plus 1 by b is 3 by 10, right? Just take the LCM. So in the LCM it will be a and b will be multiplied, it will be ab, and a is there, so it will be b into the numerator of this fraction. So here plus a equal to 3 by 10. I hope this step is clear to you. b plus a by ab equal to 3 by 10. Then you know the value of b plus a. What? A plus b is b plus a, that is 15. So put up the value of b plus a from here, equation number 1. So it will be, tell me what? 15. 15 divided by AB. What's the value of AB? Not known to you. Don't worry. Leave it as it is. AB equal to 3 by 10. Right? Now do cross multiplication. 15 into 10. Or you can simply 3 and 15, it will be cut by 5. So 5 into 10 will be 50 equal to AB. So this is one of the equation which you are having. Let's say this is equation number 3. AB as 50, right? The value of AB is calculated as 50. So we are having two equations with us, a plus b equal to 15 and 1 by a plus 1 by b equal to 3 by 10. What we did, we have taken the second equation and just come to a conclusion that second equation can be written as 50 equal to AB. What we did in between, we put up the value of a plus b as 15, right? Now do one thing, 50 equal to AB. So replace the value of A or B in equation number 1 from here, right? So what is equation number 1? So the equation number 1 is A plus B equal to 15. This is equation number 1, right? A plus B equal to 15. And here do one thing, let it A leave as it is in place of A, keep it as it is, and in place of B use this relation, the from equation number 3, B is equal to 50 by A, right? From here you can write it. So just put this value of 50 by A from here to here. So 50 by A will be there in place of B and here 15, right? Taking the LCM A, you will be having A square plus 50 equal to 15. So A square plus 50 will give you 15A, right? Isn't it? Now in the next step, A square, just bring 15A from RHS to LHS to form a simple quadratic equation. I hope you are understanding it. Minus 15A plus 50 equal to 0, right? Now what we will do, A square minus, just split this middle term. The middle term is 15 minus 15. So can't we write it as minus 5A minus 10A plus 50? I am explaining you why I have written minus 5 and minus 10. Minus 5 and minus 10 is just written it over here because minus 5 and minus 10, when you will add up, it will give you minus 15, and when you will multiply it, that means this term, when we multiply it with this term, you will get the product of the first and last term. A 50A square you are getting when you multiply minus 5A and minus 10A, right? So taking A as common from these two terms, we are left with A minus 5, right, from these two terms. And when minus 10 is taken as common, you will getting a minus 5 in the last two terms also, right? And here you can see a minus 5 and a minus 5. So bring a minus 5 as common from both these terms, because there are only two terms now. This is term 1 and this is term 2. So a minus 5 is taken as common, and after that you are left with a minus 10 equal to 0. So on solving you are getting a minus 5 equal to a minus, this will give you a minus 5 equal to 0 and a minus 10 equal to 0, and finally you are getting a as 5 and a as 10. So two answers are available with you, that is a equal to 5 and a equal to 10, right? So when you are putting this value of a equal to 5 and a equal to 10 into this equation, that is b equal to 50 by a. Here you can see b equal to 50 by a. This is the equation number 3, which is derived from the second given relation. So since b equal to 50 by a, can't we write it, if a as 5, then corresponding value of b is will be 50 by 5. So which will give you 10. The value of b is 10, right? So b equal to 10 is the value when a is 5. So the value of a and b are, it's 5 and 10, or just putting up the value of a as 10 into b equal to 50 by a. So here you are getting b equal to 50 by 10 when you are putting the value of 10 for a. So this will give you the value of b as 5, right? B as 5. So either 5 or 10, or b as 5 or a as 10. So 10 or 5. So these are the two values, and this is our answer, right? This is our answer. I hope you understand this question, students. Yes. So I've explained it. I think any doubts you can just put up into the chat box. Yes. I hope I explained it very clearly. But any doubts you can just put up into the comment box. Yes. So students, I have explained you the questions of this quadratic equation. Now I'm going to take another question from my sorts. Okay. So let me take it up. What's the second question? Let me see. There is very good question of vectors. So should I explain it? Though I have given, just put up the shorts and video of that. I will explain that. But before that, I want to take a question of fluid. Okay. So in that question, what will be taking 1 minute. A block a block of material has a density rho 1 and float 3 by 4 submerged in a liquid. So there is a liquid. Let us understood it. there is a liquid and a block is there which is submerged 3/4. So if the block is like this, if the block is like this, it's just say it's submerged 3/4. So it is dipped into water by 3/4 of its height, like this, right? So a block of material has a density rho 1. So the density of this block is given as rho 1. Rho 1 is the density, right? And float 3/4 submerged in a liquid of density rho 2. And the density of this liquid is given as rho 2. So if this is just submerged, we can say if this is water, density of water is rho 2, right? This is the density of material, or you can say block, and this is the density of water. Rho 2 is the density of water, right? Now, into this question, we need to show that rho 2 equal to rho 4/3 R1. Rho 2 equal to 4/3, not R1, it's rho 1. Rho 1. This we need to prove. This is the question. Okay. So I'm just explaining that sort which I put into my channel. Okay. Now, in this question, the volume equal to, in this question, the weight of this block will be equal to the buoyant force, right? So what is the weight of the block? The simple formula which we apply over it is, since the block is floating, so the weight of the block will be equal to the buoyant force. Buoyant force, right? The weight of the block. What is the weight of this block? Buoyant force, right? So what is the weight of this block? Weight of the block is given by this density rho 1, right? So let's say if the volume of the block is V, then we can say that rho 1 V to G, right? Rho V is the weight of the block, and this will be the balanced by the buoyant force. And what is the buoyant force? The buoyant force will be applied on this block when this is 3/4 dip. So you can see this is dipped by 3/4. The corresponding volume will be, in place of V, it will be 3/4. it will be 3 by 4. So the buoyant force will be given by rho 2 and the new volume, that is, this will be buoyant force will be applied only that will be equal directly proportional to the weight which is submerged into the water, right? So this is given as for 3 by 4. Here you can see 3 by 4. So the volume will be also equal to 3 by 4 V, and G will be constant, right? So here just cancel out this G and G, V and V, then you are getting the relation rho 1 equal to rho 2 into 3 by 4, right? So from here you get the value of rho 2, left it into the RHS, and then 4 and 3 will be coming into the LHS by cross multiplication, rho 1. Rho 2 equal to 4 by 3 rho 1, which we are about to prove, and this we have proved it now, right? So this is a very simple question, so we can solve such questions also. Now there is another question which I am going to take, that is also numerical of physics. Where we will be taking a question where two forces need to be calculated. Let's say F1 and F2. It's a question of vectors. Okay, it's a question of vectors where the F1 and F2 forces need to be calculated when it's given that, let's say, I'm drawing the question over here. Okay, if this is towards plus y direction, let's say, and this is towards minus y, if you're considering it on the number line, and this is F2 and this is F1, we need to calculate the F1 and F2 values when it's given that 1 Newton of force is applied over here and this angle is 45, right? And another 2 Newton of force is applied over here, and this is also 45 degree, and 2 Newton force is applied over here, right? Now F1 and F2 equal to what? This is our question. F1 equal to what and F2 equal to what? This is a very simple question, students. You can just break up the components of these forces, 1 Newton and 2 Newton. When you break the component, what you will see here, it's 45 degree. Then, just like a free body diagram, I am drawing it for the 1 Newton force. If 1 Newton force is like this, 1 Newton, then this angle is 45, then the corresponding this angle is also 45, right? So the components of 1 Newton, and this is a body P, let's say from point P is mentioned. Okay, so here it will be the component of 1 Newton forces will be like this here and here, right? So the two components are, if this is 45, you can see here, this will be 1 cos 45, and this will be the component which is acting along this direction. This is 1 sin 45. Just apply Pythagoras or trigonometrical ratio concept. So this will be 1 sin 45. So two components of forces are broken over here. That is 1 cos 45 towards the horizontal and 1 sin 45 towards the vertical. Right? Similarly, for the 2 Newton force, this will be component of forces which can be broken, right? If this is 2 Newton, if this is 2 Newton and this is 45, then obviously this angle will also be 45, because for any quadrant it's 90 degree. So if this is 45, then we can say this angle is also equal to 45, right? So when you break the component of this, one component will be acting in this direction, that is vertically, that is 2 sine 45. So we'll not writing it over here, we'll writing it over here, right? So 2 sine 45 here and 2 cos 45 here, right? So two components of this vector is broken. Okay. Now, when you will see the actual diagram, it will be looking like this. It's 1 cos 45 towards right direction, that is 1 cos 45 degree, and in this direction another force F1 is given to you, which we need to calculate, and in left side you are having this component 2 cos 45, the component of 2 Newton force. So that is equal to 2 cos 45. Any other horizontal force which is acting towards left. So both of these forces will be in equilibrium. If here we have P, this is the P, right? We have broken the figure actually. Okay. So here the value of 2 cos 45 will be equated with 2 cos 45 will be equated with 1 cos 45 plus F1, because this is the total force which is acting in east towards the right direction, towards the plus x. Let's say it's plus x, right? So this will be compensated by the total forces acting into the minus x, right? So equating horizontal components forces, net force acting horizontally will be 0. So we considered net horizontal force equal to 0, right? So thereafter this equation will come. So we from here we will get F1, leave it into the RHS. It will be 2 cos 45 minus 1 cos 45. This will be 2 cos 45 minus 1 cos 45. So it will be equal to 1 cos 45. So this will be equal to cos 45 1 by root 2. So 1 by root 2 Newton is the value of F1 we have calculated. This is our answer, 1 by root 2 Newton. This is the value of F1. What is the value of F2? The value of F2, you can see F2 is acting vertically. So as we have equated net horizontal force as 0, similarly we'll do net vertical force as 0. Okay. So what are the vertical forces? Let us see. This is 1 sine 45 from P. This is 1 sine 45, the component of 1 Newton force acting upward. So I'm writing it over here. And another force component, that is the component of 2 Newton acting vertically upward. So another force will be this one, 2 sine 45, right? So both these forces will add up, since the net vertical forces equal to 0, we can say that 2 sine 45 plus 1 sine 45, 2 sine 45 plus 1 sine 45, this will be equal to the total net force acting downward. So what is the downward component of force? That is equal to F2. You can see here F2. Just putting up the value, 2 sine 45 plus 1 sine 45. 2 sine 45 plus 1 sine 45. What's the value? You can tell me. It's very simple. 2 sine 45 plus 1 sine 45 will be 3 sine 45. Right? And what is the value of 3 times sine 45? This will be equal to 3 into sine 45, and the value of sine 45 is 1 by root 2. So this will give you 3 by root 2 Newton as the value of what? F2. Right? So students, we have solved this question also. Any doubt, you can just put up into the comment box. So I've explained how to solve such questions of vectors where the different components of forces are given to you, and you need to calculate the unknown quantities. Here F1 and F2 are two unknown to us, which we have calculated. Thank you for watching, and just happy learning. Bye bye.